Okay, we are doing problems on compound stresses. So yesterday's problem was a 2D plane. So one stress is acting in x direction, correct? Is this the problem?
Yes, sir. 120
Yeah.
Newton.
Another is 80 Newton per millimeter square.
80.
Very typical problem, okay, which can appear in the exam. So in competitive exam also you can see such type of problems. Okay? So the system is under an action of shear in two dimensions. One is along sigma x, correct? One is along sigma y. Is this correct? 80 Newton per millimeter square.
Yes, sir.
Yeah. So now we are interested to find stresses on an plane, okay, which is inclined at the angle theta. Correct. So theta is given. How much? 30 degree.
30.
Yeah. See, one more thing you have to know. In the question, just read that. Find the normal tangential and resultant stress on a plane 30 degree to the plane of major principal stress. So, do you remember which is the major principal line and minor principal line? Major principal axis and minor principal axis. So, this x axis we call it as major principal axis, and this y axis we call it as minor principal axis. Assuming this has not assuming it is 30 degree, okay, at the same. So initially it will not be like this. So you have to find out the angle oblique plane angle theta. But in the question they are saying that this oblique plane is making an angle 30 degree with respect to the major principal axis. Major principal axis. Is that clear? So this oblique plane is making an angle of 30 degree with the major principal axis. So eventually this also becomes theta, because if you take any reference line like this, these two will be parallel and adjacent angles will be 30 degree. So anyways theta will be 31. Okay. Is this concept clear? So theta is 30 degree. What other data you can get from here? Sigma x 120 Newton per millimeter square, correct? Solve along with me, okay? Sigma y 80 Newton per millimeter square. Okay. Now take the formula. Theta is there, sigma x is there, sigma y is there. Shear stress is not there. So you have to understand that this is a system of two-dimensional stresses or biaxial stresses without shear. The shear is zero in this case. So what is the formula? Quickly go through the formula. Sigma n, normal stress. What is the formula? Quickly. Yesterday I've written it down. Sigma n. Sigma x plus sigma y by 2, correct? Plus
Yes,
sigma
sir.
x minus sigma y by 2 cos 2
Cos
theta.
2.
Correct. Cos 2 theta. Okay. Now sigma x and sigma y value you know. Substitute that and find out. 120 plus 80 by 2. 120 minus 80 by 2 cos 2 theta means it will be 60 degree. Can you find out this value? Very simple and typical problem. Direct problem. Tell me the value quickly. 120 plus 80 by 2. This will be 100, correct? 200 by 200. 120 minus 80 by 2. And also please note this. Okay, there can be compression also. Not necessary that every time the forces should be tensile only. So here both the cases are tensile. So I have taken sigma x and sigma y both as positive. If in case there is compressive force acting on this in y direction, then you have to take it as negative. Okay, is that thing clear? If sigma y is a compressive in nature, compressive force is added, then you have to take minus 80. So in this case, it is positive. Tell me the value quickly. Cos 60 degree.
70.5.
70. Are you sure?
Sir, I'll check again.
Yeah, 1 second. Just check it. You must be getting 110 Newton per millimeter square. 120 minus 80. 20. 20 cos 60. Make that in degrees, okay? Your calculator. If it is in radians, change that to degrees. Because angle is in degrees here. Next, find out tangential stress. What is the formula of tangential stress? Sigma t or tau t. Sorry, sigma x minus sigma y by 2 sine 2 theta. Sigma x is 120 minus sigma y is 180 minus 2 sine 60. Quickly, what is the value? 120 minus 80 by 2. Are you getting 17.32 Newton per millimeter square? Shri Krishna, but are you solving? Navneet, Manuel, John.
Present, sir.
Solve the problem and
Sir.
give the answer. Attendance I'll take later.
17.
Direct question this is. There is no gimmick or anything. Sigma x, sigma y is given, theta is given. Formula is here. You have to solve.
Yes, sir. 17.3.
Okay. Let us go to the next question. Okay. Slight change here in the same. Everything, formula, everything will remain same. Write down the next question. Write down. The direct stress at a point. The direct stress. Direct stress at a point in a strained material are 100 Newton per millimeter square. Compressive. See, now it is compressive. Compressive and 60 Newton per millimeter square tensile. Are you understanding this? Compressive and tensile. as shown in figure. Shown in figure. Find the stresses. Find the stresses on the plane AC. Plane AC. Okay, is the question clear? Look here, in x direction, now it is compressive. How much it is? 100 Newton per millimeter square. Sigma x. Sigma y is tensile. Is that clear? Sorry. 60 Newton per millimeter square. Sigma y. So sigma x will be negative in nature because it is compressive. So take the values sigma x. Okay. There is also one more data given here. Plane AC is like this. Okay. It's making an angle 25 degrees. AC. Plane AC is like this. What will be theta? So oblique plane angle theta is now 25 degrees. So sigma x is minus 100 Newton per millimeter square. Sigma y is tensile in nature, 60 Newton per millimeter square. Theta is 25 degree. Is that clear, all of you?
Yes, sir.
Now apply the same formula. But one change you have to do inside tensile, instead of tensile, you have compressive. 100. So plus, sorry, 100 is negative, right? So minus 100 plus 60 by 2 plus minus 100 minus 60 by 2 cos 2 into theta means 50 degrees. Okay, tell me what is the value quickly.
Sir, minus 142.84.
Minus 142.84. Is that correct? Is this correct? Check once again. You don't need to put sign because minus means you can write compressive. Say 100 minus 60. This will be minus 20, correct?
Sorry, sir. I didn't.
Yeah, yeah, yeah. And please consider the negative sign. So this will be minus 20. 160 by 2 minus 80 cos 60 degree. Sorry, 50 degree.
Minus 64.
Sir, minus 71 point.
Why different values? Have you made the calculator in this degree mode? Anyway,
Sir, I am getting minus 71.4.
Sigma y is 10 shell, correct? It is 60.
minus
Much are getting
64.27.
54. Huh? Okay, I don't have a calculator. So I cannot calculate. What about tangential stress sigma x minus sigma y by 2? Sigma x is 100 according to the sign convention, minus 100 minus sigma y is 60 by 2 sine 2 theta means sine 50.
Sir, minus 61.28.
This value sigma m, no?
No. Sigma T, sir.
Sigma t. Okay. How much it is?
Minus 61.28.
61.28. It is
Minus
compressed.
61. Sir. Minus
Okay.
61.
Minus means you can write compressive. Okay, you can write
Okay, sir.
like that. You can write Newton per millimeter square. Okay, let us quickly go to the next type of problem. So one more category is there in which you have to include shear also. So that also derivation we have done. Before that, they have asked you to find out the resultant stress also. Find the stresses means everything you have to find. Normal stress, tangential stress, resultant stress. What is the resultant stress? Formula. Resultant stress formula is square root of resultant stress and its angle. Okay. Resultant stress is formula is square root of sigma x. And simply you can find out the square root. Sigma x square plus sigma y square. What is that formula? Sigma x square cos square theta plus sigma y square sin square theta. How to find out the angle between the resultant stress? So if normal stress is like this, tangential stress is like this, and resultant stress sigma r is like this, then this angle is phi. So tan phi sigma n upon sigma t. Okay, that will give you the angle phi. So this is how you calculate the resultant stress and the angle of resultant stress. Correct.
Sir, 95.84.
Okay, now let us go to the next problem. Now let us see a problem with the biaxial stress system with the shear. Okay. If you add a shear component, what will happen? Some formula will change. Okay, try down. The state of a stress at a point, state of a stress at a point in a strained material is shown in figure, as shown in figure. The determine first one, the direction of principal stresses, direction of principal stresses, sorry, the direction of principal planes. Direction will be for planes, not stress. Planes, magnitude of magnitude, that is you have to calculate the value of principal stresses, sigma 1 and sigma 2. We have discussed. We also have to find out the equations for sigma 1 and sigma 2. Magnitude of the principal stress. Third one, magnitude of maximum shear stress, maximum shear stress and its direction. And its direction. So where the maximum shear is there, what is its direction? Okay, and you also have to calculate principal stresses, sigma 1 and sigma 2, and you have to calculate the direction also, in which angle this principal planes are existing. Okay. So sketch is like this. Quickly write down sketch. Meeting will end now. So shear is there now. So 180 Newton per millimeter square is like this. One more tensile force in y direction, because tensile stress will be there, and another is shear. See, now there is shear. Three components are there. Okay, tensile is there along x and y, also shear. So sigma x, sigma y, tau. Three are there. We are not calculating normal and tangential stress here, so we don't need an oblique angle or theta. Theta is not required. There is no oblique plane now, because using this values you have to calculate the principal stresses. Okay. Try to solve this. Okay, I think the time is up. Correct. Okay, you quickly go into next session, 9:45, 9:46 already. I'll end the meeting here. Okay.
Okay.